Hello all. In this video we are going to talk about loops in C++, and as you know there are three loops in C++: for loop, while loop, and do while. Where while and do while are very similar to each other, for is different in the fact that for, when you use a for loop, we know ahead of time how many iterations we are going to repeat some commands, some task. While loop, we don't know, and we keep going until some condition is satisfied. So, and the same for do while. So let's look at the for loop. So here, I want to use for loop, and I want to calculate the factorial of a positive integer number. So I define two integers, n and fact, and I start fact at 1, and then I keep changing it until it's the factorial. So here I'm asking for a positive number integer from the user, and I get n. And then in this for loop, I'm going to start my variable I at 1 and keep increasing it one at a time until it is equal to n, less than or equal n. And each time I multiply the fact by I and assign it back to the fact, right? This fact is your factorial. So you know this asterisk equal means what? Means fact equals, basically this is the same as saying fact equals whatever it was times I. That's the same as saying that. So basically I start at 1 and then keep multiplying by I, where I starts from 1 and goes all the way to n. And since I'm starting at 1, actually I can start my I from 2 all the way to and the only problem is if the user enters 1 for me, then this for loop is not going to be executed at all, because you go I from 1 and then less than or equal 1, right? So as I said, I can start this from 2 if I want to, because then it's going to be 2 less than or equal 1. So this is never going to execute, and all you will be left with is fact equal 1, which is indeed 1 factorial. So if I want, I can make it to go from 2. But basically that's what you do, right? So what I'm doing here is, first fact is 1, right? First fact is 1. With that you enter the loop. Then I is 1. So your fact becomes what? Your fact becomes whatever it was, which is 1 times 1. So it's going to be 1. Then I becomes 2. And your fact becomes whatever it was, which was 1, multiplied by I, which is 2. So it becomes 2, and it keeps going, right? I becomes 3. And then fact becomes whatever it was. That was now 2 times 3. Becomes 6, and it keeps going until it is basically at the end of the day, fact is what? It's going to be 1 times 2 times 3 times 3 dots times n minus 1 and then times n, right? Once you get this, then the result is going to be what? N factorial, of course. So you see this task of multiplication of fact by I and reassigning it back to I have to repeat that n times. And since it's the same task being repeated so many times, and I know ahead of time how many times, n times, I use a for loop, right? So here I use for loop, and that is going to give me the n factorial. And let's go ahead and run that. So here I say 6, and then you know 6 factorial is, of course, what? 720. So anything that I can repeat, and I know how many times I'm going to repeat, I use a for loop for it. And of course, all the code that needs to be repeated should be inside the braces. Now, a few other things about the for loop is, 1, inside the basically first line of a for loop, you are not limited to only change one variable. You see here, I have my loop counter, I start it, I define it, declare it. I can declare it, I start it or initialize it. I have the end condition for it, and I have the increment for it. Okay. Now I can have more than one variable. So I say, hey, I have both JJ and KK, start them at 1. While they are both less than 10, go ahead and add 1 to each one of them and give me what? 10J plus K and show it on the screen. So basically, what am I going to have? J is 1, K is 1, so the first number is 11, then they both become 2, so it becomes 22, 33, 44, and so on and so forth. And this is exactly the set of numbers that you can see here. Now you might wonder, can I use nested for loops here? Can I have nested for loops? So for example, if I want to show all of the numbers from 1 to 99, right, which you know it needs nested for loops, it needs one for loop within the other for loop. Can I do it with a single for loop like this? And the answer is no. Why not? Because here I'm changing J and K at the same time. It's not like I keep J constant, I just change K, then once all the changes in K happened, then I go ahead and change J to, let's say, 1, add 1 to it, and then repeat the procedure. So since I'm changing both variables at the same time, or both loop counters, this is not equivalent to what? To a nested for loop. If you want to show all of the numbers from 1 to 99, not just like 11, 22, 33, then you need to use nested for loops. And how would you do that? Let me add it for you here. So here I only go with J. Okay, I only go with J and I only change J. And within that, what am I going to do? I also need to change K as well. So inside that, I'm going to have my second for loop, which is the interior for loop, right? This is the exterior for loop. So now I'm going to copy this line and I'm going to have it here. This time I have KK. And now inside this, I'm going to show my numbers, which is 10 times JJ plus KK. And I'm not going to use end line because that is going to show all of my numbers from 1 to 99 all below each other. If I want to go every 10 numbers in a line, then I need to put some space like this, right? And then when that thing is over, then I go ahead and add a line like this. Okay, so I can go to the next line. So this one should give me what? As you can see, the outer loop is J, the inner loop is K, and I'm showing all 10J plus Ks separated by space when the row is over, or when K has changed all numbers from 1 to 10 and J is about to change, I go to the next line. So this one should give me all the numbers from 1 to 90. Actually, in this case, yeah, I guess that's right. Let's go ahead and do it, see what we get. So here, let me just enter a number. So here, you can see it gives me all of the numbers. Of course, it is skipping over 20, 30, 40. Why? Because my KK only goes to 9, not 10. And I can fix that. I can take care of that, right? So all I need to do is my JJ goes from 0 to 9, but my KK can go from 0 to 10. So I should say less than or equal 10. Okay, and that should do the job for me. And let me just add another extra line here. So let's try it again. There we go, right? You see now I have all of my numbers. And if I want to include 1 to 10 as well, then I need to make sure that this number here goes from 0 to 10, not from 1 to 10, correct? So now you see I got all of my numbers. So again, this idea of changing more than one variable within a single for loop is not equivalent to what? To, let me add something for you here, to nested for loops. And one other type of for loop or format for a for loop that we have is called in range. This is the kind of thing that you have in Python. So here I'm defining a vector, and this vector here has 8 numbers, 2, 3, 5, all the way to 19. I call it primes, and of course these are prime numbers. And now I want to go and type the content of this vector here, right? Or this array here. So how do I do it? Instead of me saying for I goes from 0 to length of this prime minus 1, show prime entry I say int m in primes. So m here is the content, is the entry, not index. M is not index here. M is the value 2, 3, 5. So I say for m inside or belonging to primes, go ahead and show it. You see? So here I'm not using any index. Not using index. Just using, as long as this is in range, this is inside primes, this value m, go ahead and show it. And you can see that here, right? You see? It is going to show that. So use a for loop, but no index for a vector or array. Okay, so that was for loop and nested for loops and everything. Now we have two other loops, that is while loop and do while. As I said, the difference between these two and for loop is we don't know how many iterations we're going to have ahead of time. We keep doing something until some condition is satisfied. So here again, I'm going to calculate the factorial of a number for you, but this time with a while loop, not with a for loop. Although, of course, it makes sense to use a for loop because I'm doing a product n times. But I want to show you that you can also do it with a while loop if you want to. Because while in general is more powerful than a for loop. While keeps going until some condition is satisfied, and this condition is, for example, the loop counter becomes equal to n. So here you see, I have I, which is the loop counter, n, which is the number by the user, fact1 and fact2, and these are the numbers of factorial calculated by while loop and do while. They're going to be the same number at the end of the day. So here, the first thing you need to do for a while loop, you have to initialize the loop counter. Unlike a for loop that initializes the value for you, the while loop doesn't. So you have to do the initialization yourself. You need to initialize the loop counter. It doesn't do it for you. Then you say while some condition satisfied, keep doing some operations. What is the condition? While the loop counter is positive. So, and look here, I'm starting it at the n. Last time I started it at 1. Here I'm starting it at n. I keep what? I keep multiplying fact1 by I and assigning it back to itself, and I'm decreasing I1 at a time until it reaches 1. When it's 1, still doing it. When it reaches 0, then this condition is not satisfied anymore. The while loop would stop. And you would get, of course, the product of all numbers. So last time, what you got was 1 times 2 times 3 all the way to n. What you do this time is what? You get fact1, you start it at n, and then each time, as you go through the loop, you multiply what? By a number that is 1 unit smaller, correct? And keep doing that until fact1 becomes n times n minus 1 times dot 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 times 2 times 1. So you're going backwards, okay? Or you can start it at 1 and keep going until it's less than n. You can do it the same way as a for loop. I'm just doing it a little bit different so you can see different ways to do it. So we mentioned that when you have a while loop, you have to initialize the loop counter. The other thing you have to do is to change the loop counter. Okay? You have to change the loop counter yourself. It's not like a for loop that is going to change it for you like this. You have to put that command over here. You have to change the loop counter. You have to initialize it, you have to change it. And the while loop can, for example, check your loop counter or any other complicated Boolean operator or Boolean values. So it doesn't need to necessarily be just loop counter. It can keep doing it until it receives something from the user or so. So that's the power of while loop. It can handle complicated scenarios instead of just looking at a simple loop counter. But keep in mind that you need to initialize and you need to change the loop counter in a while loop. Okay? In do while, the overall thing is the same. You have to initialize, you have to change everything. The only difference is in while loop, you first check the condition. I added for you here something. You first check the condition, then you run the commands. In do while, you first run the commands. Then at the end, when everything is done, you check the condition. And that's the only difference between them. There is no other major difference between them. So this is while and do while, and you see if I run them both with an integer, I can easily get what? Get both of them to give me the right factorial. Okay? So just keep that in mind. But that's the major loops. That's all of the major loops for while and do while. The only thing I need to tell you to be careful about is this end condition. Since the order is reversed, in this case, you see I used I bigger than 0 and I bigger than 1 for while and do while. Now, if I change this and make it 0 or change that to make it 1, in this case, you're not going to see any difference because I start them at 1, okay, and 1 factorial is 1 and 0 factorial is also 1. So you're not going to see much of a difference in this case, and I'm not even dealing with 0 factorial, right? So, because this code, as I said, the goal of this code is positive integers. If I want to try them with 0, right, you see, now, look, my code is not doing it right. You see, it says 0 factorial for while is 1, but for the other guy is 0, right? Because when you get it 1, what's going to happen? This one is not going to run, right? Because you start I at n is 0, so this condition is never going to run. So your factorial is going to stay at 1 and it's going to be printed out. The other one, you start I at 0, but you don't check whether you should multiply it by anything or not. So you bring that 0 and you multiply it by what? Multiplied by factorial, which was 1. So you make factorial 0, and then you say, okay, now I see that 0 is not bigger than 1, so let's go ahead and stop. But when you stop, you already ruined factorial 2 and you already made it 0. Okay, so what? So you clearly ruined the 0 factorial by multiplying a 0 by 1 and typing out a 0. So you see, I can use the while loop here. While loop can easily handle 0 factorial for me, but do while doesn't. Do while does not do it. If I want to do it, I have to change how I start I and when is it that I would stop it. Okay? So be careful about when and how you can use while versus do while, because do while first does the job, then ask you to check the variable. While is more cautious. I personally always prefer while. I would rather first check something, then use it, than to use it and then check it. So my suggestion is use a while loop. I don't see any advantage in do while. Okay, so to me, while loop and for loop are really the major loops that you can have in C++. Thanks for your attention. I will see you in the next lecture.